Hello, hello, Shagathanoon here. Welcome back to another Rust coding stream here on the 28th of December, 2022, local time 10. And let's get started by doing a quick little recap of what happened last time. We call it prefabs and sectionals or room sections. And if we take a look here, it's very hard, it's very fast, it's very hard to see. But if you take a look, it generates a cellular automata map, but on the right-hand side, there is a fortification that is pre-designed. And we look again, we see it pop in after the cellular automata map, but we're getting a different cellular automata map every time, which is pretty cool stuff, right? So if we begin the game, we can walk around this cellular automata map, and then as we get over to the side here, we're in this pre-designed fortification area. So we now have the ability to load in a map of any kind. So cellular automata, we could build one with wave function collapse. It doesn't really matter. We can load in any kind of map and then feed that map into this prefab thing, which will then slap the fortification on the side, which is pretty cool stuff. So there's a little glimpse at it. We're going to be adding more today. Today's session is called vaults, so room vaults. So I believe the idea here is that we're going to be taking a map and saying, let's carve out a section of the map to put like a room in here with maybe a bunch of items or something. That's the idea. Now, if we look at the scroll bar from last time, it's a bit smaller than today, so this one might go a little bit quicker. So we'll see how it is, right? And I'm going to be, once again, judicious with, if it's something that I don't think will benefit from typing, I will copy it just for brevity. And I think that's the right approach at this point. I always say you should write new code yourself, but if it's something that's too boilerplatey, I don't really see a problem at a point with copying some of it. But it's still good for muscle memory, for repetition and everything, so just keep that in mind. So we're going to get started here on room vaults. The last chapter was getting overly long, so it was broken into two. In the previous chapter, we learned how to load prefabricated maps and map sections, modified the spawn system so that meta builders could affect the spawn patterns from the previous builder, and demonstrated integration of whole map chunks into levels. In this chapter, we'll explode room... Explode? Well, I'll say explore. We'll explore room vaults, prefabricated content that integrates itself into your level. So you might handcraft some rooms and have them seamlessly fit into your existing map. Designing a room, totally not a trap. The life of a roguelike developer is part programmer, part interior decorator, in a weirdly gnome mad scientist fashion. We've already designed whole levels and level sections, so it isn't a huge leap to designing rooms. Let's go ahead and build a few pre-designed rooms. Now, this is one where I'm going to be copying. Now, take a look closely here. We're seeing only 6 lines here, and I don't think, or why did I say 6? I can count, I promise. We're seeing this like 3 by 3. In my brain, I think it added those together. We're seeing this 3 by 3 of traps with like a potion in the middle, right? So that might be what we're getting, or it might not be. I'm gonna have to go into the raw file to double check, because copying these strings previously from this page has led to some problems. My mouse is still doing that. I upgraded OBS a couple days ago, and it was fine during yesterday's Dwarf Fortress session, and now it still does it here, which is odd. Oh well. OBS upgrade helped. It's still good. Does it do it in here? It seems a little better in Visual Studio, but not great. I rebooted yesterday. I didn't reboot today. I don't want to reboot every stream. But I will if I need to, I guess. All right, enough of that distraction. So we're going to make a prefab room file. So in prefab builder, we're going to say new file, prefab room.rs. Now, this is pretty basic boilerplate kind of stuff. So let's just read what it is for the sake of brevity. This is similar to the prefab levels and prefab sections, where we have a struct that contains like the template, the width and the height and all that information. So we have the same thing here. The template is our raw, is our string literal. We have a width and a height of the thing that we're putting in the map here. And we have first depth and last depth, which is new. And my initial guess is this is something that's going to be able to span the map over different layers of the dungeon. That sounds cool. I guess we can see how that works. Now we're going to need the totally not a trap string. If I were to include this in the mod here, prefab room, we would see that we're getting some issues in here because we don't have totally not a trap map. So let me duplicate my tab over here. And now we're going to scroll to the bottom. I said we're going to scroll to the bottom. We're going to go to the source code. Source. Map builders. Prefab. Prefab room. They may have added more. Okay, so that is all we're seeing here. But we do see other ones. There are other ones that are going to show up. So I'm going to copy that from here to make sure that there are no hidden characters, which was the issue we had yesterday. We had hidden characters showing up, or something along those lines. There were hidden characters that were not being properly copied, and I said yesterday, whatever, though, last session. So that'll make sure we get the actual string that we're supposed to be using, so it's not going to break things. But notice it is a 5x5, so the string is like this. You can actually see it kind of highlighting there. That emptiness around the traps is part of the string, so you have to make sure you get that exactly as it should be. Okay, so if you look at the ASCII, you see a classic piece of map design. It's a health potion completely surrounded by traps. Since traps are hidden by default, we're relying on the player to think, well, that doesn't look suspicious at all. Not that there are spaces around all the content. There's a one-tile gutter around it. This ensures any 5x5 room into which the vault is placed will still be traversable. We're also introducing first depth and last depth. These are the levels at which the vault might be applied. Okay, for the sake of introduction, we'll pick 0 to 100, which should be every level unless you're a really dedicated playtester. Yeah, so I was thinking it would be a, like, factoring in Z levels for some reason, but no, that doesn't make sense. I should have thought a little bit more about it. It'd be cool to have something that factors in Z levels, though, where you have a room that... just imagine like a big chunk carved out of like 3 layers of the dungeon. That'd be cool. So now, we're going to place the not a trap room. So we're going to add another mode to the prefab builder system. This thing we just put is the not a trap room. It's a joke name, right? I said it the way I said it. My inflection made it sound like the not a trap room was something separate. I had to clarify. So we're going to go back to the prefab builder and add another mode to it, which is the room vaults. We're not going to add any parameters yet. So we're going to go ahead and make those quick changes. So in the prefab mod, we need our mode, and it's going to be room vaults. And then in our match down here, we'll add that. Whoops. So we'll add the apply room vaults function here. We're not going to have it quite yet. And we also want to go up to our new function, our constructor, if you will. And we're going to change that to room vaults. We're not going to add anything else here yet. So I think we're just kind of hard coding it at the moment. So the text says we're not going to add any parameters yet. By the end of the chapter, we'll have it integrated into a broader system for placing vaults. And we've got our match function now. So let's get back to it. And we see that we added the supply room vaults. So now that leaves the next logical step being to write apply room vaults. Our objective is to scan the incoming map from a different builder and even a previous iteration of this one for appropriate places in which we can place a vault and add it to the map. We'll also want to remove any spawned creatures from the vault area so the vaults remain handcrafted and aren't interfered with by random spawning. So we'll be reusing our create previous iteration code from apply sectional. So we'll rewrite it into a more generic form. I'm interested because it said there's a lot of new Rust here, and I'm not really seeing what's so new about it. Oh, wait, I do see now. Okay. So apply previous iteration. So that's going to be... in here. Now we're taking generic F, which is just a name. We could call it J if we wanted. We could call it A. There should be no real meaning behind that. In this case, there is because of what we're calling F, but it's just a name. It's a generic type. And what is F? It's a filter called F. But what is this filter? Well, here's some of the more new stuff. Where F is fn mute I32, I32, and usize string, bop, bop, and it returns a bool. Now, there is definitely a lot of new stuff going on here, but it's actually pretty nice. It's pretty straightforward. This is a nice thing you can do here in Rust that there are definitely similarities to things you can do in other languages, but the syntax is really good here. So what we're actually saying is this is a function that takes an immutable reference to self. So we call this on a prefab builder, and it takes in this second argument, or well, in the case you're calling on something, you only pass in one argument because this is called with my prefab builder dot, and then you would pass in one argument, which would be this here. And it's this mute filter, and we're actually specifying what a filter is. So a filter has to be any fn mute that takes in an I32, an I32, and a reference to a tuple with a usize and a string, which if you recall is our spawner stuff, right? That seems to be the spawner. I'm using structure as a loose term here. It's not an actual defined struct, but this is the format that we're passing things in for our spawner. And then it returns Boolean. So we're actually saying this thing we're passing in is a function, an fn mute specifically. So an fn mute is implemented automatically by closures, which take mutable references to captured variables, as well as all types that implement fn. Example, safe function pointers, and since fn mute is a super trait of fn. Additionally, for any type F that implements fn mute, a mutable reference to F implements fn mute too. That's a big mouthful, but we're going to be able to pass functions in basically, and we can see an example here with the closures, where we have this do twice function that takes in a mute func F, where F is just any function, right? Where it's just any, well, it doesn't actually, it's any fn mute that takes no parameters and returns nothing, I should say. So then we can see do twice being called with add 2 to x, which is just defined as a closure which captures and modifies x by adding 2 to it. So hopefully that makes a little bit of sense. What we're going to do is we're going to set x to 1. We're going to increment it by 4 by doing this twice, which is built into do twice here. And then we're going to assert equal that x is 5. So we've added 4 to it. We'll see how this plays out in our code here. So let's go ahead and actually write the code. So we're going to get the previous builder as mutable. We're going to build the map. Now we are pulling that out of the option, which I'm still a little bothered by. We have to be really careful that we're only going into this when we know we have something in the option. And I still don't think we've actually enforced that anywhere. I don't think we've done any checks on that. So it could be possible that we would crash if we called this incorrectly. Now the tutorial text has a .clone here, but we don't need the .clone because the getMap is already cloning and returning that, so we don't need to do another clone. Oh, whoops. Get spawn. So we're going to iterate over the spawn list. And we're going to get the index and turn that into an X and a Y. And remember the trick when you're doing the mod and divide, right? You're not doing width and height, you're doing width on both. Alrighty, so there we go. Let's break down what's going on here. We're taking in this filter, which is going to take in X and a Y. Now, this is just seeing how we're using it, right? If filter X, Y, E. Well, what is E? That's our usize string. So remember, we defined this fn mute is going to take in I32 and I32 and this usize string tuple. So that's what we're passing in here. And if that returns true, then we push the spawn, we push it into the spawn list, whatever the current thing is that we're looking at in our existing spawn list. That's really all there is to it. The filter is going to tell us what condition we're satisfying. So we're probably going to build a simple closure which allows us to make those decisions, and we can make different decisions based on different filters at different parts of the code. Now, this is not actually the same thing as self.spawnList.iter.filter. This is not the same thing, right? We're passing in a function which is doing a job of filtering, which is kind of the same, but we're not talking about the exact same thing as calling filter on an iterator. You could argue that there may be a way to do it. It would also maybe get a little messy with some of this code. There may be a way to do it, though. I'd have to rework this myself and think about it. All right, one moment. All right. So our text says, there's a lot of new Rust here, so let's walk through it. You'll notice we've added a template type to the function. Function apply previous iteration f. This specifies that we don't know exactly what f is when we write the function. The second parameter, mute filter f, is also of type f, so we're telling the function signature to accept the template type as the parameter. Before the opening curly bracket, we've added a where clause. This type of clause can be used to limit what's accepted by the generic type. In this case, we're saying that f must be an fn mute. An fn mute is a function pointer that's allowed to change state. Mutable, if it were immutable, it'd be an fn. When we then specify the parameters of the function and its return type. Inside the function, we can now treat filter like a function, even though we haven't actually written one. We're requiring that function accept two integers, I32s, and a tuple of usize and string. The latter should look familiar. It's our spawn list format. The first two are the X and Y, are the X and Y coordinates of the spawn. We're passing that to save the caller from doing the math each time. And we then run the pre-builder code we wrote before in the previous chapter. It builds the map and obtains the map data itself, along with the spawn list from the previous algorithm. We then iterate through the spawn list and calculate the XY coordinates and map index for each entity. We call filter with this information, and if it returns true, we add it to our spawn list. And then lastly, we're going to take a snapshot of the map so we can see the step in action. Sounds really complicated, but most of what it has done is allow us to replace the following code and apply sectional. I don't know why I can't read today, apparently. Okay, so where is this apply sectional? So this is everything here, right? So now we're gonna say, I'm gonna have to retype the comment because I highlighted it and I didn't want to re-highlight. I think I could have actually, I want to try something now. If I highlight like this, can I then do, yeah, I could have done that. Shift down. Why did I type filter? Okay, so we're going to apply previous iteration, and we need to build a closure now to pass in. I should have kept these conditions because they're a bit annoying. So we have X, both of those. Now we want to check Y. Y is less than chunk Y. Or Y is greater than chunk Y plus section dot height as I32. And that's it. That should format. And that's a lot nicer. All we're basically doing, as is pretty clear here, we're passing in the function that we're going to use to filter. We already know what the previous builder is because it's stored in self. So we don't really need any other information here. We don't actually have, the tricky part here is we don't actually have an X and a Y right here. We don't even have an E. What is E, right? Actually, I am interested in that. Oh, I think, yeah, I understand. Because in this case, we're not using E, right? So in this case, I think we don't need to worry about E. But in other cases, we will. So in this case, all we're doing is checking where something is at, right? When we're applying the sectional, we just care where it's at. In the case of other ones, we actually want to get E and do stuff with it. I believe that's the idea. But we do have access to X and Y in here. And that's because we're actually like defining them right here. And if I tried to do something like this, we would see that we fail because the closure is expected to take 3 arguments and we can't find X. So X is coming from this definition of the closure, which we're passing in. So it's not going to be until down here and up in apply previous iteration where we actually use those values, pass those values in. And again, that's where we do this if filter line here. So if filter is going to say if, and basically run this code here. Interesting way of doing redirection, but it's going to be reusable in multiple cases where we can pass that closure in. So it's actually going to be nice. So back to our text. This is interesting because we're passing in a closure, a lambda function to the filter. It receives x, y, and e from the previous map's spawn list for each entity. In this case, we're checking against chunk x and chunk y, section.width and section.height to see if the entity is inside our sectional. You've probably noticed that we didn't declare these anywhere in the lambda function. We are relying on capture. You can call a lambda and reference other variables that are in its scope, and it can reference them as if they were its own. It's a very powerful feature, and you can learn about it here. So now on to room vaults. Yeah, by the way, capture and move are two very powerful things about closures, and it is worth understanding both capture and move. All right. So room vaults. Let's start building apply room vaults. We'll take it step by step and work our way through. So we'll start with the function signature, and it's going to have no parameters other than mutable membership of the builder. It's going to be referring to types in prefab rooms. So rather than type that every time an in function using statement. Wait, so hang on. It is going to be referencing. Sorry. Is going to be referring to types in prefab rooms. So rather than type that every time an in-function using statement imports the names to the local namespace to save your fingers. Oh, I see. Yeah, the wording threw me off for some reason. So rather than doing it every time, comma, an in-function using statement imports the names to the local namespace to save your fingers. We'll also need a random number generator, so we'll make one as we have before. And then next up, we'll start doing a couple extra things. So let's go ahead and start writing that instead of going too far ahead. So right up here, we'll do this right here. We have prefab room versus rooms. I'm going to fix that. Actually, I'm going to double check the... Yeah, it's plural. It's going to bother me. All right, so we'll put that use statement to just bring everything in. RNG, random number generator, new. So then we're going to do this. Apply the previous builder. And keep all entities it spawns for now. We just blanket return true. And we're saying we're not using those, so just underscore it. Now we're going to go... So the text, by the way, says we use the code we just wrote to apply the previous map. The filter we're passing in this time always returns true. Keep all entities for now. Next. So we're going to make this master vault list as a placeholder. And it's a vector of all the different vaults. Now for a normal filter, but you'll notice because filters take closures, it is similar to what we've done here in a way. But again, it's not the same thing as using a filter on an iterator, right? I wanted to make that clear because we're calling the thing we passed in a filter. Do not mix the two up. So let possible vaults be a vector of prefab room. And this is where we're going to do it. .iter, .filter, v. And V is a name. We could actually, instead of saying V, we could say vault. I might do that. It's nicer. I often do one-letter variable names on my filters, though. But I'm just showing that it's a variable name. You can call it what you want. Now remember, .collect collects it into whatever type we have here. We could do something else. We could do a hash set, prefab rooms, or not. Oh, because we don't have equality defined. Well, if we had equal defined and we need hash and stuff, we need to be able to hash them to put it in a hash set. But my point stands. We could put it in a linked list. And that's actually perfectly happy to do that. We're doing a vector, and I mentioned this before, but if we don't put that there, it's going to complain because it doesn't know what type it is. I think you can also do a turbofish here, and you can do an underscore, and that works as well, and it's collected to a vec of references to prefab rooms. So the other thing is here, we could actually put, let's say I put prefab room without the reference, it's going to complain because a value of prefab room cannot be built from an iterator over references to prefab rooms, right? So I could put the thing here and we're good. So if you want to do inference into a vector, you can be lazy about it and do that. And say you've got some weird type in the middle and you don't want to figure it out or type it out, you could do that. Now, can you do that up here? That's a good question. I don't think I've ever tried up here. Yeah, it looks like you can. But we're going to leave it as prefab room. Just want to show a couple things with how inferencing on collect works. But yeah, if you remove this, it doesn't know how to collect it. Type annotation is needed. Because it can collect any number of types of collections, right? And it actually says here, because it's so general, it can cause problems with type inference. So one of the few times you'll see the syntax known as a turbofish. And we see an example here. They say veci32, a vecdec. Here we have collect with the turbofish, and so on. All right. So simple filter. If self depth is greater equal to the first and less equal to the last, making sure it's a floor that we can put it on. That's all we're doing here. We're just filtering out and collecting only those that we can use as possible vaults. Easy enough, right? If possible vaults is empty, bail out if there's nothing to build. Crap. Is it just possible? Oh yeah, it's a big old beefy one. Okay, what are we doing? Actually, I don't need that. I need that. Sorry, their formatting was different than mine and it threw me off. Mixing up the parentheses a little bit there. It's kind of, sometimes it's easier if you type this on your own, but when you're like, what is the exact thing we're doing? And you have to like scroll back and forth on the tutorial side, it can be a little confusing. So, yeah, we actually don't need these. I'm not sure why they were there, but they were there. All right. So there we go. And we're not done yet. We're not like done with the function, but let's break down what's happening. So once we've got our list of possible vaults, if it's empty, we're done. Otherwise, we get a vault index. If there's only one vault, then our index is 0. Otherwise, we do a random dice roll to the total length of however many vaults we have, right? And we make sure it's offset by 1 because indexing starts at 0. So the tutorial text also explains that we make a vector of all possible vault types. There's currently only one, but when we have more, they go in here. This isn't really ideal, but we're worried about making it a global resource in a future chapter. We then make a possible vaults list by taking the master vault list and filtering it to only include those whose first depth and last depth line up with the requested dungeon depth. The iter filter collect pattern has been described before, and it's a very powerful way to quickly extract what you need from a vector. If there are no possible vaults, we return out of the function. Nothing to do here. Finally, we use another pattern we've used before. We pick a vault to create by selecting a random member of the possible vaults vector. So next up, make a list of places in which the vault could fit. I always find that phrasing 0 U size a little bit weirder than just specifying U size. I mean, it's valid, but it's a little strange to me. All right, mod divide, width on both. We're getting our X and Y values, and then we're converting it into I32. So there's a lot of casting here. Index is a U size because we're going to be indexing with it, so that makes sense. Our map and width is an I32, or our map width is an I32. Oh, I said map and width. It's an I32, so we have to turn it into a U size to work with the index. And then once we're done, we need it back as an I32 for the X and Y. So a little bit of back and forth there, but you got to do it sometimes. I don't know where I got those from. Okay. So what we're checking here is, well, it's stated already. Just making sure we don't overflow the map. We want to make sure our X is greater than 1 or Y is greater than 1. And then we're basically doing X plus or Y plus the vault width and height, because we need to make sure, like, if the vault is 5 wide, we need to make sure we're more than 5 to the left of the, or we're 5 or more to the left of the right extent of the map. So that's all there is to it. Map.width -2 is just kind of building in the borders and stuff. We've seen that before. So we're going to default to being true for ty in 0 to vault height as I32, for tx in 0 to vault.width as I32. We're going to make an index of tx plus x and ty plus y. And we're just looping over the vault here, basically, and making indexes for all that. So the way to think about this is essentially, for the vault width and height, it starts at 0. So at first, it's whatever x is. It's not 0, 0 that we're starting at. It's x, y. And then each of those increment through the double for loop. So, and it's being offset by our x and y value on the map. And we're going to keep incrementing that index. So we'll be doing that in a minute. So basically, we say if it's possible, or if it's not floor, then it's not possible, right? So we'll go down. And once we've looped over the entire vault, think about it as looping over the patterns like we saw before. As we've looped over the entire vault pattern, if possible, we can just use XY because they share the same names. We don't have to do X:X. So if it's possible, then we break the loop. Now, what I'm seeing here is the loop we're breaking. The loop we're breaking is this outer loop here. Make a list of places in which the vault could fit. It's not going to be a list, though, is it? I mean, if a single one is possible, we break out. If our index gets too long, we're at the end of the map, we break. This should almost be continue. Or not continue, but, well, no, it wouldn't be continue because we still want to do our index. We should just remove this. Otherwise, we're only ever going to have a single entry. Am I misreading this? So let's break down what's happening. We create an index. We have this empty list of vault positions. We get an X and Y. We check the map boundaries. If it is within the map boundaries, then we loop through the X and Y values of the vault. And if everything is floor, we're still true. So if everything was a floor, then we push that vault position into the list and then we break. But the only loop we're inside of is the outer loop there, which controls our index and everything. So we're going to end up breaking out of that loop once we've put a single thing in here, which to me defeats the purpose of making it a vector. So I guess we might be changing that. Let's go ahead and read what's happening. And at the end, we just increment the index straightforward down there. So let's take a look at the text. There's quite a bit of code in this section which determines all the places a vault might fit. Disagree. Just so you see, we're looking at it here as well. If possible, just break. We make a new vector of positions. This will contain all the possible places in which we could spawn our vault. We set index to 0. We plan to iterate through the whole map. We start a loop, the Rust type that doesn't exit until you call break. We calculate X and Y to know where we are in the map. We do an overflow check. X needs to be greater than 1, and X plus 1 needs to be less than the map width. We check the same with Y and the map height. If we're within bounds, we set possible to true. We iterate every tile on the map in the range X to X plus vault width and Y to Y plus vault height. If any tile isn't a floor, possible is set to false. If it is possible to place the vault here, we add the position to our vault positions vector from step 1. We increment index by 1. If we've run out of the map, we break out of loop. Let me go in here real quick. Bit of a spoiler alert, but what was this one called? Here we are. That break is still here. I don't see how that works. Am I just completely missing something simple here? We'll simmer on this for a bit and maybe look into it. In other words, we quickly scan the whole map for everywhere we could put the vault and make a list of possible placements. We then, I'm going to add like a log statement as well. After we get out of the loop. I think we might need to do format here. So total number of vault positions, and we're going to get the length of it, because I don't really believe that. I think the break seems incorrect. I think with the break, it will always just grab one vault position unless I'm missing something. All right, so let's keep moving on now. So after this, if it's not empty, oh. Wait, is it not usize? Oh, I do need to do this one here then, don't I? Okay, what am I missing? Oh, it's the len. That's the one that's getting me. I think we do that and we're good. Yeah. Alrighty. So a simple pattern we've seen before. Just got to make sure you get your types right. I've been typing it from the text so long that it took a moment to get the types right, but it's not bad. I didn't feel like scrolling over the text because it's still glitchy. So again, simple pattern. If there's only one, then our index is 0. Otherwise, we roll a random index, and we use that position, that index that we've got here, to get something out of the vault positions. We'll get our X and Y for the chunk values, and we'll do let string vec equal prefab. That's not how I did mine. Mine's not in prefab builder. Maybe it should be, but mine's not. So we'll just do this. We'll get vault.template, and that gets us back a string. We wrote that last time. That gets us back well, it gets us back the string as a vector of characters, rather. We'll do a for ty and tx loop. And there we are. So this is kind of stuff we've seen before for the most part, but we'll quickly run through it. If there are vault positions, we do this. We can't really do anything if there are no vault positions. If there are vault positions, we get a random index from it, and we get that position. We convert, like we wrap out the chunk X and Y, or wrap out, we pull out the chunk X and Y values from that position that we randomly found. We convert the template of the vault to one moment. Oh no, right. Vault is, I was just gonna confirm, we got vault up here with that same pattern. So we've already randomly picked the vault. So we get the template of the vault into a string of characters, or a vector of characters, I mean. And then we do this pattern here that we've seen before. We loop over the vault width and height, essentially constrained by those values, right? So we offset it by the chunk X and chunk Y, and we kind of constrain the loop by the vault's width and height. And we just set the characters into the map, which is this self.char-to-map that we wrote before. Straightforward enough, I think. Not that bad. So if there are any valid positions for the vault, we're going to pick a random entry in the vault positions vector, and this is where we place the vault. We'll use read ASCII to vec to read in the ASCII, just like we did in the prefabs and sectionals. We'll iterate the vault data and use char-to-map to place it, just like we did before. Putting it all together, you have the following function. And we got a big old beefy boy. And they still have the break in here. So we'll leave it for now, but I put my little log counter because I don't believe it. And I want to see it. It's more likely that a square vault will fit in rectangular rooms, so we'll pop over to Map Builder's mod.rs and slightly adjust the random builder. Use the original simple map algorithm for the base map. So we have prefab builder taking in a simple map builder. If we cargo run, it'll probably be placed on our map. So let's take a look at it. Total number of vault positions, 1. Total number of vault positions, 1. You see what I'm saying? Total number of vault positions, 1. It's on the logs on the console here. So we're gonna go fix that. This is a bug in the tutorial text, it seems. We should not be breaking here, I don't believe. We'll leave that, we'll comment it out. Not sure why that break is there, because a lot of the other code is redundant and unnecessary with that break. We should be able to now find multiple positions, I would hope. Yeah, 112 possible vault positions. That's much better for randomness. 122 that time. So there we go. We have a bunch of vault positions coming in now. We're going to leave this code as is. The tutorial text again does have that bug in it. And I'm going to just comment that out and leave it there for now. All right, moving on. So if you cargo run, it'll probably be placed on your map. And here's a screenshot. And, you know, no wonder it's in the upper left, because that would be the first valid, that's literally the first possible place it could be placed. Because remember, the border around it is part of the pattern. So of course we have it there. What's going on for you? Filtering out entities. So we probably don't want to keep entities that are inside our new vault from the previous map iteration. You might have a cunningly placed trap and spawn a goblin on top of it. Well, fun. Probably not what you had in mind. So we'll extend apply room vaults to do some filtering when it places the vault. We want to filter before we spawn new stuff and then spawn more stuff with the room. So we'll have retain, which I think we've seen retain before, but it's always nice. I know I've used it a couple of times. So we're going to go slink back on over to here. And we want to do that. I think, do we just want to do that right here? I think so. Yeah. Doesn't like what? Let's see. All right. So we're going to get our spawn list, and we're going to do retain. So we can read here real quick. It retains only the elements specified by the predicate. So, you know, you pass in a closure and tell it what to keep, right? Simple enough. So we're going to call it E, and let index equal E.0 as I32. We're going to get let X equal index mod width. Let Y equal index divided by height. Should that be height? Or should that be width? I kind of think that should be height. Or, no, I kind of think that should be width, I mean. So let me double check one more thing. Let me see in the mod back here real quick. Now they have width and height, but typically when you're doing the divide mod, you want to use width both times. So that may be a bug that we have to address. Okay, but simple enough overall, except for this potential little issue. And we have it up above, actually. Like we could... No, where did I do it earlier? I mean, here we have an example right here. We're getting X and Y with the mod divide construct. and we use width both times. So I'm not 100% confident in that. We'll leave a note there. But overall, the retain and everything is pretty simple. We're just checking to see if anything is within the vault's extent. This, you know, the edges of the vault basically, and if it's not, then we will keep it. So that's why we're saying X has to be less than the chunk, X has to be greater than the chunk X plus the width, right? We're not trying to make sure it's within the chunk, we're actually trying to keep the things that are outside of the chunk, or outside of the vault. So calling retain on a vector iterates through every entry, calls the past closure / lambda function. If it returns true, then the element is retained, it's kept, otherwise it's removed. So here we're catching width and height to avoid borrowing self, and then we calculate the location for each entry. If it's outside of the new vault, we keep it. So what if you want more than one vault? Well, having only one vault's pretty dull. That'll be a good start in terms of proving the functionality works. So in prefab rooms, we're going to add a couple more. They aren't intended to be seminal examples of level design, but they'll illustrate the process. So once again, I need to make sure I get the ASCII characters properly migrated over. So we have a couple more that we're going to just bring in here into prefab rooms. We have the checkerboard and we have the silly smile. So this thing has a couple traps and a few walls making up the silly smile and checkerboard. That's a bit messy, but the idea is we have walls in a bit of a checkerboard pattern, and then we have things littering all around those walls. We have traps, health potions, goblins, rations, and traps, and all kinds of fun stuff. I know I said traps twice, but I was reading them as I saw them. So we've basically defined two different little, what were they, prefab rooms? Two different prefab rooms here. We have the silly smile one, which goes to a depth of 100, and same with checkerboard. So we're going to want to bring those into our apply room vaults and make sure those are included in the list of the vaults that we can use. We'll come back up here, and where is the placeholder? So we have totally not a trap, checkerboard, and silly smile. So now we run it again, we can get some different options here. Let me click back over to OBS, where I can see it better than on my monitor. And it looks like we got checkerboard over there. So if I walk over there real quick, there's our checkerboard. Heal up a bit. Wasn't there another trap down here? No, that was the only two. Well, there were two, but I thought it was on the right. So there we go. We got checkerboard. Let's run again. We have the silly smile there, it looked like. That's it right here. Now there's two blood stains for eyes. And we could probably run again and we'll get the other construct eventually. I don't know if we did or not. No, it looks like we got the smile. Yeah. Well, it's fine. We've seen that it's working. It's obviously building different ones here. And I'm a little bit confused on this part here. Why is it height and not width? What happens if I run width? What am I missing here? I'd like to... Wait, I think it was broken. Was it? Hang on. Keeps giving me the checkerboard. There's the smile thing over here. You know what's weird? It's still working, which is always odd. Oh, I understand why. That's only our spawn list. So it's still going to generate the pattern, of course. It's always going to generate the pattern. But I think it wasn't properly clearing the spawn list. Hey, we discovered that trap. Discover the other one. Do it. I don't know why I can't discover that one. There we go. All right. I'm gonna leave this for now because I think it should be divide. Unless I'm missing something, I'd like to be able to confirm that, but I think that should be divide. We've done this so many times that it's like a standard thing now. So I'm calling it, I believe that is a bug. So we've seen this now. We've added checkerboard, a grid of walls and spaces with traps, a goblin and goodies in it, and silly smile, which looks just like a silly wall feature. Now open up apply room vaults. We just did that. Add these to the master vector. If you cargo run, you'll most likely encounter one of the 3 vaults. Each time you advance a depth, you'll probably encounter one of the 3. My test ran into the checkerboard almost immediately. Notice the checkerboard's in the upper left because of that little bug. The first one. That's a great start and gives a bit of flair to maps as you descend, but it may not be quite what you were asking for when you said you wanted more than 1 vault. How about more than 1 on a level? So we're going to go back to apply room vaults, and it's easy enough to come up with a number of vaults to spawn. So let's switch back over. We're almost done here, actually. This is quicker than I expected. So we're going to go up near the top before we start deciding on vaults. And I'm just going to say let n vaults equal, and we're going to do I32 min. So we're deciding between 2 different options, right? Actually, no, we need to go a little bit lower. We're going to be using possible vaults, so we'll go here. And that actually makes sense. So we're going to do I32 min, so it just picks the minimum between a dice roll, a 1d3, or possible vaults.len as I32. Boom. There we have it. So now n vaults is going to be whichever one of those is smaller. So it'll never exceed the number of options, but it can vary a little bit. It's also pretty easy to wrap the creation function in a for loop. So we'll go here for I in 0 to n vaults. And we're going to open. And then we should close down here, I believe. So we'll take a snapshot for each vault. Notice the end of the loop. Oh, wait, I did miss something then. Yeah. We're going to take a snapshot and then possible vaults dot remove vault index. And it's not mutable, so we have to go fix that. So now, this is one case where even if you tried to do some funky stuff with iterators, you'd run into problems here because you're mutating it per iteration of the loop. So there are some times where iterators are a little more difficult to work with in cases like this. If you want to like randomly pick things from something, you can't really do that very effectively, right? You could do a random sampling with no duplicates though. You could probably do that from an iterator. Take a random sampling, ensure there are no duplicates, and then just go from there, right? I was thinking you could build a hash set. So up here where we generate the number of vaults, you could actually try to do like a hash set and just pick out 3 random indices or however many random indices you want, and then populate a hash set with that, and then you're not going to get duplicates. So if one shows up a second time, you would lose that vault, and that would be building in some more randomness, and then you could iterate over the indices of that, and there you go. Just other ways to do the same thing, I guess. So you could probably use iterators that way, and not have to worry about indices so much, and that could be a little safer in some ways, right? Iterators typically are safer, rather. I mean, you could still do weird things with them and run into problems, but iterators are going to be a lot safer because you're not directly accessing by index, and you're not risking going out of bounds or something. The iterator is going to take care of that for you. So unless you're doing something really funky, you're going to be in a much better place. So at the end of the loop, we're removing the vault we added from possible vaults. We have to change the declaration to be able to do that. So now it's let mute possible vaults. And we add mute to allow, so yeah, we're adding it to allow us to change the vector. I'm reading the text, by the way. So if it sounds like I'm repeating things, we'll just click over, fine. This way we won't keep adding the same vault. They only get spawned once. Now for the more difficult part, making sure that our new vaults don't overlap the previously spawned ones. We're actually going to make a hash set, but of tiles we've consumed. Okay. So we want to make sure those don't overlap. So we're going to say let mute used tiles hash set. And I guess we want to do that before we go into that big loop. That would be my understanding, right? So we'll declare it up here. And as the text says, oh yeah. As the text says, I should have just imported it, right? Hash sets have the advantage of offering a quick way to say if they contain a value, so they're ideal for what we need. We'll insert the tile index into the set when we add a tile. So self.char2map, we'll simply say used tiles.insert index. And then in our possibility checking, we want to do a check against used tiles to ensure we aren't overlapping. So our possibility checking is up here, right? So we have our index, and we're checking the floor to say possible is false. We also want to say if used tiles dot contains, and then the index. We could slap those into a single conditional if we wanted. It's probably not that big of a deal. So now if we cargo run, we might get several vaults. So let's take a look at it. Oh, yep, we got 2 vaults. Beautiful. There we have one of them with the goblin and the traps and the pudding pops and all that stuff. Are references to that guy no longer good? Oh, you know what? Yeah, I made the goblin walk over and he died. What a loser. All right. So there we go. We have multiple vaults popping up in the same one here. It's beautiful. We can take a look at our text here. Oh, it's going to get ugly for a second. There we go. And we have an example here. See, notice, I'm calling out that bug again. Not because I'm trying to be harsh or overly critical, but I am calling it a bug. Here we have in the upper left of their map, it seems, we have one vault. And then directly to the right of that, we have the next vault. Very interesting, right? It just so happens to be that both vaults appeared right next to each other. Or, not, well, in that order. The exact order we would expect to find if we only went with the first possible position we found for the vault. We're starting in the upper left, we find the first position, and we put a vault there. We find the next one, we put a vault there. And I would guess if they had 3 vaults, the next one would actually be here. Because that break does seem to actually be a bug, like I called out earlier. So just something I want to call attention to, because it's just interesting, right? And I think ours has that more random placement of the vaults now. So we also say I don't always want a vault. So if you offer all your vaults on every level, the game will be a bit more predictable than you probably want unless you make a lot of vaults. We'll modify apply room vaults to only sometimes have any vaults with an increasing probability as you descend into the dungeon. So we're just going to use the map depth as an easy way to do that, which we've been using before. Where do we want to do that? Apply the previous builder. So we have that. And then do we want a vault? Oh my god, I can't type at all. So we're going to do a roll dice. It's going to be a 1d6 plus the self.depth. A vault roll is less than 4. Return. So they actually get with an increasing to only sometimes have vaults with an increasing probability as you descend into the dungeon. But am I reading this wrong? Walk through this with me. We have vault roll. It's a 1d6 plus the depth. So as we go deeper into the dungeon, our depth gets larger, right? But our check is if our vault roll is less than 4. It seems to me it's going to be, at some point, impossible to get a roll of less than 4. Because if we go down to layer 5, if we go down to layer 3 even, and we roll a 1, then we're going to add 3 to that immediately, and we're no longer less than 4. But the tutorial gods say, this is what we're doing. How's it going, Tusk? So that's what the tutorial gods say. We're going to look at it. This is very simple. And by the way, this is the text here. This is what they say to do. Roll a 1d6, add the depth to it. This is very simple. We roll a 6-sided dice and add the current depth. If we rolled less than 4, we bail out and just provide the previously generated map. If you cargo run, you'll sometimes encounter vaults and sometimes won't. I mean, we could show that, but I don't think I need to show that right now. We'll do one more demo run here in a minute. But the text says, we'll sometimes have vaults with an increasing probability as you descend into the dungeon. That makes it sound like you'll get more vaults, but eventually, with this logic, you should get no vaults at some point. It should be less probable. So just a comment. You probably want to say, I don't know, there's probably a better way to do that. I don't know, maybe not. Tusk just woke up. What time is it there? It's like 17, no, it's like 18. Finishing up, offering some constructors other than just new. We should offer 1820. See, called it. We should offer up some more friendly ways to build our prefab builder so it's obvious what we're doing when we construct our builder chain. So I'm not going to type out 4 constructors here. I'm going to copy them, but we have a Rex level, which takes in the Rex level template. We have the constant. We have the sectional, and we have the room vaults. So we can use all 4 of these, which gives us essentially 4 more ways to make levels. So let's go here where our new is at. And let's plop these bad boys in here. I don't do allow dead code. I would rather Clippy yell at me about it than suppress it. Personal choice. Okay, and we now have a decent interface for creating our meta builder. So now it's turtles or meta builders all the way down. The last few chapters have all created meta builders. They aren't really builders in that they don't create an entirely new map. They modify the results of another algorithm. The really interesting thing here is that you can keep chaining them together to achieve the results you want. For example, let's make a map by starting with a cellular automata map, feeding it through wave function collapse, possibly adding a castle wall, then searching for vaults. The syntax for this is currently quite ugly. That'll be a future chapter topic. It's okay. Ugly is subjective. There's a lot of boxes there. Prefab sections is private. Go to it. Can we, prefab builder, prefab sections. That's not what I need. I need in here. All this is pub. Do I need to do pub mod here? Yeah. Why did I have to do that? For that one in particular. That's because the only one we have here. The others are probably going to complain as well. Okay. So we're boxing up first cellular automata builder. Then we're doing wave function collapse on it. Then we're doing a prefab builder on it with underground fort. And then we're attempting to add vaults to it. Oh, whoops. I completely missed the thing. I'm so sorry. I don't do that often, but I did today. So what I had to do was come in here and add pub mod to this. If I remove it, we were getting a complaint here that this is a private module. So let's go ahead and head back in here and do pub. Actually, the tutorial mentions to do all 3. So let's just go ahead and do all 3 because we're going to need to do that anyway. All right, and let's run this, and we're almost ready to wrap up. It was a quick one today compared to the last couple. I have no idea if it applied any vaults or not. I wish we had a map reveal scroll. Is that one? What if that is one? No, it's magic missile. Get away from me, stupid goblin. I want to see the map gen. Map reveal scrolls are pretty rare. I could jack up the spawn rate for them. I think I'm going to do that. Let's go to our spawner. Where is spawner? The weight on that is going to be 2,000. Spawn me all the magic mapping scrolls. It's going to be nice when we change this to being data driven. There's one. Because we don't have to compile every time. Alrighty. I don't see any of the vaults that we put down. We did get our fortification on the side, which is cool. Let's run this a couple of times and see if we get one. It's going to take a lot of luck. Oh, I did see one. Begin new game. There it is right there. And notice, despite the weight that I put on that, our vault thing here enforces that we have a goblin, some rations, a health potion, all that stuff spawns here. We also have a trap. See, I stepped on it. So now probably every other spawn we find will be a magic mapping scroll. Anyone see the stairs? They should be showing up. I just straight up almost did a Caves of Cud thing where I tried to like auto path to stairs. I wanted to go down to the next layer. Is it because we haven't personally seen them yet? Or is it because I'm blind? I really do want to make it there. We are correctly adding stairs, are we not? Oh my god, I see them. They're on the edge of the map. They're over here. So now we have a new map, and we can magic map it with all the scrolls we have. And I don't see any fortifications here, or any vaults here. Nothing's standing out. I do see the stairs. We can go back up this way. Go down to another level. Magic map. Yeah, still not seeing any notable structures, any vaults. And I don't think we will now. Remember the bug that I outlined. That's why I'm testing this. The bug that I outlined tells us that we should not see anything else, basically. Or we should not see any more vaults. Go down. There we go. Okay. Well, there we go. There we have it. Let's change that back to a 2. Let's go back over here. So we made everything public. If we cargo run, we get to watch it cycle through the layered building. We did not actually get to do that. We're going to restore randomness. We'll come back in a moment. I want to look at something. Now that we've completed a 2-chapter marathon of prefabricated layered map building, it's time to restore the random builder function to provide randomness once more. Here's the new function. We can do that when we're ready. We're taking full advantage of the composability of our layers system now. Our random builder now, in the first layer, we roll a 1d17 and pick a map type. We've included a pre-made level as one of the options. Next, we roll a 1d3, and on a 1, we run the waveform collapse algorithm on that builder. Then we roll a 1d20, and on a 1, we apply a prefab builder sectional and add our fortress. That way you'll only occasionally run into it. And then 4, we run whatever builder we came up with against our prefab builder's room vault system, the focus of this chapter, to add pre-made rooms to the mix. So in this chapter, we've gained the ability to prefabricate rooms and include them if they fit into our level design. We've also explored the ability to add algorithms together, giving even more layers of randomness. Now, we have a problem that we've been having for a bit, and it seems like I think I know what the cause is. When I generate this, take a look at this. It's very fast. We don't get to watch it generate properly. It's too fast. It's skipping, it's removing the history. I think what we probably want to do here, when we're using an existing map, let me find it. Apply previous iteration. Do we also not want to do self.history equal prev builder dot get snapshot history? And for that, do we need to clone, or is that no, it's a clone. I believe we need to do that, and we need to do that in wave function collapse as well. But let's take a look at it now, and it should be a little bit better. Yeah. Look at that. That's all we need to do. So we've been having that bug for a bit, and I was like, I kind of want to deal with it. But, I mean, we're watching their builder, and theirs does it, and either I missed a line somewhere, or they didn't have it in the text. So let's take another look at it real quick. Activate browser. And let's go in here and look at the prefab builder stuff. Let's look at the mod and apply previous. Apply previous iteration. They are copying the history. Okay. Now let's go look at this real quick. Oh. You can click on stuff in here? Whoops, did I not copy? Okay, whatever. Aha, look at this. Tell me I'm wrong. We get the map, we build map, starting position and map, and then we start the for loop. But over here, build map, starting position, map, history, and then we start the for loop. So we see the problem here, right? That's something that was not in this text here, but was in the raw source code. Be resourceful if you're doing this stuff and look for little issues like that, because that's been making our maps hard to watch generate, and now it's a lot better. So we're going to go into wave function collapse mod. And where we use the derived map, we're going to also copy in the history. Get snapshot history. Help if I put a semicolon. And we're going to cargo run that. And we're going to see an even longer map gen. We're going to be able to watch it do the cellular automata here. Then we're going to be able to watch it waveform collapse it. So there's our cellular automata map. Now we're doing wave function collapse on that cellular automata map. This is way more interesting to watch, I think. It's obviously, it takes a lot longer, but... And now we add the fortification, but we can't reach it. I would hope that that fortification got called, but I don't know if we're doing that in the prefab sections. So we could take another look down here in build. Remove unreachable areas. Yeah, we are doing that. So it probably got called. We just didn't get to see that last bit. Because that last bit happens too quick. So we'll take one more look at another example, running through the whole process. So we build a cellular automata map. Now we use wave function collapse on it. Now we will be putting a fortification that we can reach, it looks like. Oh, we actually failed. We failed that one, so we're regenerating it. Remember, wave function collapse can fail its heuristics. Oh, what? Oh, there's a bug somewhere in there. We'll have to look at that. I've pretty closely followed the tutorial, so I'm not going to be bothering with that right now. That's the first time we've seen that happen. It looks like one thing we would want to do is validate our starting position again after we do a lot of this extra work. I think we're kind of keeping an existing starting position at one point that we shouldn't be. There, we actually did everything on that one, which is cool. We got to see the whole thing work. And we have our little fortification thing over here and everything. Awesome. Do one more. See what it looks like. Cellular automata. Wave function collapse. Now put the fortification, which we can reach, and it put a pattern. It put a vault. We did everything. Awesome. Next, that was a weird one though, where it just stuck us in the middle of nothing. So it seems like there is a latent bug somewhere. I believe it is in wave function collapse. We'd have to look more into it, but it's never happened before. That's one of those that's hard to debug. That would be where it would be nice to be logging your seeds or something and then have a way to easily seed or unseed your random number generators. That would be good. That way you can work with it and figure out what's happening. Because that's the only time we've seen one do that. So next up, we are going to go ahead and re-randomize the random builder. Clippy's going to hate this thing that I'm copying. For one simple reason. It might hate it. No, it doesn't hate it. But we don't need to save that in a variable. We can just do that. Just return it like that. So now we have our map looking nice and happy. We can generate all kinds of maps and do all kinds of stuff with it. So let's take a look. What do we get? Cellular automata again. Hey, it's random now. And wait, what? And wave function collapse. I have a hard time buying this. We rolled a 1d17 and got the same algorithm we've been looking at. We didn't add a fortification that time, though. So that was different. And I didn't notice if we did a vault or not. So it was different. We rolled a 1d17 and got the one algorithm we've been testing over and over hard-coded. And then we rolled a 1d3 and got a 1, so we did the wave function. Very interesting odds there. So now we have a binary space partition interior map. I'd like to see this get wave function collapsed. I think we did once. We build our doorways and stuff. And there we are. Give it another run or two. This looks like, is this Drunkard's Walk? I think it's Drunkard's Walk. No, this is depth limited, diffusion limited aggregation, DLA. Put a couple different vaults in there too. This is Drunkard's Walk. Are we going to collapse it? Nope. Oh, we are. We are collapsing it. I saw a vault. Cool. I think that is good enough for today. Take a quick look at the browser. It's going to get ugly. Go. So we look at our scroll bar. It's just past this horizontal bar here. Next session is going to be a bit longer. Layering / builder chaining. I think there's some builder pattern stuff going on here. It's a pretty profound approach to procedurally generating maps. Oh yeah, so I think we're using the builder pattern. So I think I understand what's going to happen. We're making a map builder, and then on that map builder you can keep calling things and say build this, build that, add this, add that. So builder pattern is pretty popular in Rust. I've seen it in, the first time I ever saw it was I think in Java, but it's pretty popular in Rust. I see it all over the place. So we're going to make a builder map, and then you give it this builder chain struct, and what it's doing is it's holding starter and it's holding all the other builders, and then it's going to automatically apply them one after another. So this will be next time, but I'm just skimming through it. So it's going to be a big old refactor. Room-based starting position, room-based stairs. Putting it together to make a simple map with the new framework. Cleaning up BSP. Same again for BSP interior. Oh, it's going to be a big old boy. Updating Drunkard's Walk. So next one is definitely going to be a long refactoring session. A very long refactoring session. But look at what we have. Now this is the power of the builder pattern, which is very syntactically pleasing compared to what we've been doing. What we've been doing, I'm fine with boxing up, but it is like a lot of like nested boxes and stuff. So here we say, give us a builder chain, call it builder, and then start with, that's our initial builder, a Voronoi cell with the Pythagoras algorithm. And then also wave function collapse it, then add vaults, then do the starting position. We want to specify a starting position, call the unreachable areas. So we're going to be removing call unreachable from every single map thing and making it more generic. Then we're going to do Voronoi spawning on top of that. So we're also making that more generic so that the maps aren't responsible for spawning things anymore. And then we're going to be doing prefab builder sectional to add the fort. In that case, we're always adding the fort, but we'll make it random. And then we'll be adding a distant exit at the very end. So the exit could be in the fort or it could be somewhere else. So there's a lot going on there, but that's pretty cool. Like you could just keep adding stuff if you want. Now, there may be some combinations that don't make a lot of sense to do, but we could add the vaults later if we want, right? We could have added the vaults before wave function collapse. And then they would no longer be a pre-made vault, but it would add new things in to be shuffled around with wave function collapse. So that's, you know, another interesting thing you could do. You could add the fort before the wave function collapse, right? And then that would be part of what gets shuffled around and could lead to interesting things. So there's a lot of cool stuff there. And then we're going to be doing, we're going to be making an initial map builder and just giving that back out, and random initial builder, and then a random builder. And we're going to have some of the same logic, but it's actually a lot shorter and cleaner than it used to be. At least the separate parts. If it has rooms, do that. Otherwise, do this. So we have like different ways. Oh, it's going to be good. I'm looking forward to it. It's a big old beefy boy though. And that's the power of the builder pattern though. Builder pattern, the idea is you initialize with some default working values. So the idea is your constructor, your new function, would give you everything you need to build the map, to be done, right? But you can then add more things to it. So I've done that before when I was working with an API. I looked at their API and I said, okay, well, there's a bunch of stuff here that we may not want to do, but there is stuff that we have to do. So my constructor takes in all the mandatory things, and then all the things that are optional, they get set to default values. So if it's like, how many results do you want back? That's an optional thing. So the default value might be 25. So I just set it to 25 as default, right? And that's like the API documentation is like, this is the default value if not specified. So I either set it or or let it auto figure out, right? You see what I'm trying to say? But then I would have fields that I would say, okay, well, we want to make a call with number of results. We want to make a call with this thing, with that thing. So we keep doing .with, adding the different components that we want. And then at the end, we say .build or .make request, whatever it is, right? And we get the final result where it like pieces it all together for us and does the actual work. So it's a really cool, really nice pattern to work with. It's not the hardest thing to build. No pun intended, builder. It's not the hardest thing to do. I had seen it before in Java. I never made my own for a long time. And then one day in Rust, I was like, let me try a builder pattern. And I was like, oh, that was actually really easy. So we'll see how it goes. It should be fun. I'm looking forward to that one. Refactoring is not the sexiest thing, but it is nice when it makes the code better to work with for future things. But we're not going to be doing that much more map generation in the future. Not that many more map generation algorithms. Do the layering, fun with layers, room builder, better corridors. So we're going to be, it looks like, just modifying some of the stuff that we refactor next. So I think we're like officially done. Kind of bittersweet moment, but I think we're officially done with actual map generation algorithms. And next it's going to be modifying, cleaning up, working with what we already have. So a little bittersweet now that we're done with the prefabricated stuff here. But it is how it is. That's how it goes, right? Okay, so let's pop back over here. I'm going to do an outro, and we'll watch this thing build a few more times. So thank you to anyone who showed up today, whether you're lurking or chatting. I appreciate it. If you are new and you like coding, if you like Dwarf Fortress, which I'm playing right now, or Caves of Cud, which I'm playing right now, Stars from the Divine Force, Genshin Impact. I'm about to wrap up Star Ocean and start up something new there as well, so who knows what that'll be. If you're interested in any of that stuff, I do play all kinds of other games as well. Play all kinds of stuff. Hit that follow button. You can leave the notifications on to see when I go live. I would appreciate it. You can also head on over to YouTube, or if you're in the future watching this on YouTube, then congrats on being in the future. But do all the fun YouTube stuff while you're over there. Like, subscribe, notification bell, leave a comment. I do read my comments, and I try to respond to all of them. Let's see what happens to this one, by the way. I want to see if it gets collapsed. I hope it does. So you can do all the fun stuff. I do read my comments. You can also follow me on Twitter. I know in the past, Tusk, and I think someone else complained about Twitch notifications not being reliable for them. They would come in like an hour late or something. So if you do have those problems, or if you don't trust them, then you can follow me on Twitter, where I do post every time I go live. You turn the notification bell on there, and it's pretty reliable in my experience. So there you go. And I guess that's it. I really want to see a BSP interior get collapsed. I might have to, I think we did it before, but I might have to force it to happen. Ooh, this is an interesting one. The Voronoi Hive map getting collapsed is cool. Oh, I see some areas that are getting called. We'll do one more. We'll force it to do the BSP and collapse and vault and everything. I think it'll be cool. And then we'll wrap up there. I guess that was my outro. I think I said everything I needed to say. Ooh, that's really funky. Hard to navigate, too. Yeah, very hard to navigate, because we got plopped in the center. Hey, I beat that floor! My goodness. Yeah, we need some heuristics for wave function collapse. I mentioned this before, but we need some heuristics on total space. We basically count the floor tiles, and if they're after culling, if there are too few floor tiles, maybe redo it, because that's not a fun map at that point. That's pointless. It didn't even spawn anything, so you don't get a chance to get any equipment or anything from it. Like, it's kind of a pain. So result is BSP interior builder with the depth. I think that's all we need. Oh, right. New. I was like, what am I doing? Let's take one look at this. Oh, well, let's take a couple looks until we get it to collapse. I know I could have changed the RNG roll and stuff, whatever. So we're getting our BSP. I really like these. I would like it to be a bit more heuristics driven, to make it a bit more like of a logical layout for an interior. This is very algorithmic, and you can tell, but it's still pretty cool. Here we go. Yeah, I'm pretty sure I tried these a couple times and got mixed results, but I do like it. That's a pretty robust map. Cool. We actually got to keep most of it. Alrighty, so with that said, that's my outro. We're about 2 hours. That's not bad for a session here. And I think next session might be long. I am glad next session is a day that I am still off work. It was the 2nd, right? Because we go back the next day. It's the 3rd. Yeah, we are off the 2nd. So I get to have another early session. And I want to say this in the right way. Get it over with. But I mean that in a good way. Like, if I could do all my streams early, I kind of would. Like, get up at 5 o'clock in the morning and stream for 4 hours or something. I don't want to do that, right? And then start working. If I could do all my streams more midday, I would definitely do that. But I can't because of work. So that's the unfortunate side of it. But it's nice to be able to get the stream done early and feel like I accomplished that, and then I have time to myself. I have a mental thing, and it actually could be a symptom of something that I'd like to get checked out. But I have this thing where if something is coming up, it can be 2 hours from now. All I can think about is that that thing is happening in 2 hours. And I feel like there's not enough time to do anything because that's now there. It's an impending thing, right? It's now there. So all I can think about is that. So it's like not enough time to do something else, but it's too much time to just sit around doing nothing. And I'm really bad about that. So getting it kind of earlier in the day is nice. I wake up and I do morning stuff. I shower. Maybe I eat, maybe I don't. But like it's easier to kind of take care of all that. And then now it's almost time to stream. I don't really have anything else. 15 minutes. That's perfect, right? Something like that I like. So it'll be nice. And if Monday is going to be a long session, it'll be nice. I don't have to cram it in after work and then run potentially late and then make Tuesday more difficult, It has that cascading effect, right? So anyway, again, thank you to anyone who showed up. If I can talk, thank you to anyone who showed up. Just blur it all together. And until next time, have a good day, have a good night, whatever it is, wherever you're at. Take it easy.